So first off, I'll kind of introduce ourselves as Arconic. We've only existed in this name for about a month now. November 1st, Alcoa and Arconic separated. Alcoa was rolled out and Arconic kind of took on the downstream, if you will, the engineered products and solutions portion of Alcoa. So Alcoa will remain as the mining, smelting, refining side of the business, and then Arconic is all of the things that would suit automotive and other industries, aerospace as well. So sheet metal and fasteners and engineered solutions. So the two that will probably interest this group the most are the ones that I highlight, the Arconic fastening systems and rings, and I caught myself there. I'll probably say Alcoa again before I'm done, so excuse me for that. But the two groups that probably interest the automotive segment the most are Arconic fastening systems and rings, full series of structural blind fasteners, lock bolts, threaded inserts, and that type of thing, as well as what I'm going to introduce today, but also our rolled products group that supplies sheet metal to automotive customers as well as aerospace customers. So as far as automotive is concerned, our automotive support and presence, we have sales and manufacturing and support locations all around the globe. I'm actually from our North American group. I sit in a desk in Waco, Texas at one of our manufacturing plants. We have a large technical development facility in Pittsburgh, Pennsylvania, where some of this technology was developed as well as a location here in Telford locally. So the technology I'm going to introduce is really best described as a hybrid of welding and mechanical fastening. And so to that end, it was developed by a collaboration of our technical center in Pittsburgh, who have a lot of mixed material welding, joining, aluminum development experience, as well as my group that is headquartered in Waco, Texas, that has a lot of experience in mechanical fastening and joining. So this new technology is a hybrid of those two schools of thought, welding, mechanical fastening, and kind of brings some of the best of those two worlds together. So a lot of you have probably seen a chart like this in your experience and over the last few years. A lot of companies are choosing to specifically go down one of these two paths in terms of vehicle lightweighting. They're either going the upper path, which is aluminum intensive, like you would see in the Ford F-150, or they're taking the other path, which is mixed material architecture. And there's pros and cons to both approaches. The mixed material would be more like what you're seeing in the Cadillac CT6, where you're very selective about using high-strength steel and maybe your safety cage, but because you're more comfortable with that and going with aluminum in your closures and outer panels. So, but we feel that our technology is well situated to help you out along either one of those paths that you choose to take. So in general, RSR is you have your rivets that we show on the left-hand side, either in steel or in aluminum, and then you add that fastener to your existing steel spot welding infrastructure or strategy. You feed these rivets to your weld at the weld station, and then you can make the weld with that rivet in the joint, and you get the cross section that you see on the right side, which is an example of using the steel RSR to join an aluminum panel to a steel panel. So you're not, with this technology, you're not actually welding the top sheet to the bottom sheet. You're welding the fastener to the bottom sheet and capturing your top sheet, but you still have a nice rigid joint there. And so that allows you to join a large variety of materials as your top sheet. So obviously your bottom sheet needs to be a metallic sheet, and so that's either steel or aluminum, and then you choose the fastener to match that bottom sheet. But then you can join either metallic or non-metallic sheets to that bottom sheet. So it can be painted or unpainted steel or aluminum, it can be plastic, it can be just about anything that you can imagine. The large majority of our development so far has been mixed material, aluminum to steel, and the reverse. So I've got a couple videos if we We found a way to make those work that words only go so far to describe what you're seeing with this process. So there's two ways that this works. This is the first, where you actually have a pilot hole in the top sheet and the rivet passes through it. So in this case, that's the pre-prepared top sheet. Those are the fastener themselves. So there's our feed system with a top hole. And that's all the time that the process takes. So it's very comparable to cycle time to existing what we're introducing is the fastener and the feed system. And then you just add that to your weld cell. So then there's a second video as well that shows that if aluminum is your top sheet, with a steel fastener, you would not have to have a pre-pierced hole in the aluminum sheet. The steel fastener can heat up the sheet and force its way through. We'll see this is slightly slower cycle. Similar, whether you have the pilot hole or not, you still get some moderate